Hi everyone. Today I'll be walking through difficult contest problem A from Educational Courses round 181. And first I'm going to read the problem, and after that you can try to solve it on your own, and we'll walk through the solution together. And so problem A, difficult contest reads: it is known that a contest can be represented by a string S consisting of uppercase Latin letters that denote problems. It is also known that a contest is difficult if it contains FFT or NTT as a contiguous substring. Your task is to rearrange the problem in contest S in such a way that this contest is not difficult. If the initial contest is not difficult, you may leave it as it is. Alright, and so the input gives you T test cases, and so that's the number of problems that you want to solve. And so every problem, as described in the problem statement, contains a string S and has a length of at most 20,000. And so another constraint that's noteworthy to mention is that the sum of the total length of strings does not exceed 2 times 10 to the 5th. And so that's just basically saying you won't need to input that much data. And so just try to solve this problem on your own, and we'll walk through the solution after you do so. Okay, so assuming you've tried this problem, let's just walk through some example test cases. And so a very good problem solving strategy is to just try some example cases on your own and see if you can come up with a general algorithm that solves the problem. And so let's just look at the first test case, FFT. And so if we go back to the statement, we know that a contest is difficult if it contains FFT or NTT anywhere as a contiguous substring. And so in this first example test case, the string is FFT, which obviously there's one occurrence of FFT or NTT. And so that occurrence is FFT, and that occurs once in the substring. That's just the whole string, right? It just says FFT. That's the occurrence. And so let's go through the second example. And that example is going to be ABF. So I'm going to write it down. So I'm going to write S2 just to denote that this is the second test case. ABFB, oops, it's a weird looking B, and ANTTA, Okay, and so I'm just gonna fix this B because it looks quite weird, just for sake of readability. Okay, so now let's determine if, well, first, right, we need to, what's our original task here? We need to arrange this string such that it doesn't contain either FFT or NTT in it. And so let's just check if this string actually has an occurrence of FFT and NTT. And as you'll see, we'll just try to come up with a general algorithm that maybe rearranges these letters as we do so. And so let's just scan through it. So because we can first note that FFT and NTT are both strings of length 3 because they have 3 characters in each of them. So we can just scan through and just see if there are any occurrences, 3-letter occurrences of FFT or NTT. Okay, so we can just go through it. ABF, obviously it's not either one. BFB, nope. FBA, nope. BAN, nope. ANT, nope. NTT, yep. So we've found this specific occurrence, NTT, that is exactly one of these substrings that we were looking for. And the problem statement says that we don't want either FTT or FFT, excuse me, or NTT in either one of these, or in the string anywhere. And so we want to get rid of these occurrences. Just if we can also check the last occurrence, which is TTA, but we obviously know that it's not either one of these. And so we can just rearrange, right? We can rearrange the string in any way we want. The problem statement doesn't have any conditions on how we can we need to rearrange the string. So we can just in this case, right, we can just maybe, bring n to the front, and that's just going to destroy this occurrence of NTT. And so the new string can be NAB, NAB, FB, AT, since we already got rid of the N, and then another T and an A. And so that's just one way we could do it. And so now after playing with this, we can play with another test case. So let's just try the third one. And I'll provide you some intuition how we can maybe think of a more general algorithm, more specific way we can rearrange these strings. And so another one is FFT and TT. And so that's a more obvious one because we see that with S3 is FFT, NTT. We see that we already have two occurrences of the bad substrings, and this means that the contest is the contest string 3 is hard, and we want to just rearrange it, right? Because if the original string is not difficult, then we can just print it as is. And so in this case, right, maybe we can try. Well, first we want to get rid of the FFT, so we can get rid of that by maybe putting the T over there. And then, so the string is going to be TFF NTT. And so we still have, note that we still here have NTT as an occurrence. So let's just get rid of that by removing the N. So that's, and let's bring it to the front. Okay, that's just like the easiest, most intuitive method of getting rid of like a 3-letter substring. So let's just move that. And so the string is going to be N, T, F, F, T, T. Right. And so now it's clear that we've removed the two original occurrences. But now look at what happens. We have one occurrence of FFT right here, so we still have to remove removes one of the strings. So let's just remove the first F in this the bad substring FFT over here. So it's gonna look like F and T, F T T. And so now we can see that there are no occurrences of FFT or NTT anywhere in the string, so we can just print this out. And so note that again, with these problems where you have to arbitrarily rearrange the string such that some condition is satisfied, like where in this case where certain strings are not should not be in the string, we can often do some sort of sorting technique. And so why sorting is very useful is that it's a very well-known process, like rearranging the letters in non-increasing order. And so that's often a greedy strategy that's just like very nice to understand. And so note that when we played with these examples, right, we always wanted to get rid of a substring, right, that occurred, like let's say NTT. That's a little bit bold here. So note that in each of these example cases, we always wanted to remove one of FFT of NTT, and we did that by moving a letter from each of these bad substrings to the front. And so that gives us an idea that maybe we can try to sort, and again, we can rearrange these letters however we want. So maybe let's just try sorting it. And so let's just try FFT and NTT. And so when we sort the characters, basically placing each of the rearranging the whole string such that the characters are arranged in alphabetical order. So from A to Z, we get for string 3 F N T T T T, and so that's after sorting. And so obviously, we want a general process. The reason why we want to sort the reason why we want to do that is because if we try to think about specific characters that we want to move around, that might be a little bit harder to implement, and because each character can be any letter from A to Z. And so like if we want to be super specific, like let's say if we see an NTT, then let's move the N all the way to the front. That's going to be kind of hard to implement. And the fact that this is a problem A on an eater round usually means that there's a very easy way, a very simple way to do it. And so sorting is a very good way to rearrange the characters so that the string has a property that you understand very well. And so that property here is that the letters are in non-decreasing order. So they're all in alphabetical order, right? When you learn in grade school, the letters are going to be arranged such that all the A's are going to go first, all the B's are going to go after the A's if there are any, and then C's are going to go after the A's and B's and so on. And so sorting it, right? We know that all of the letters are in increasing order or non-decreasing order. But there's a little bit of a problem because if we try to sort it, right, not all of the strings will be good to print out, because after we sorted this third string, we have a bad occurrence, and that occurrence is going to be NTT. We don't want the NTT because we want to sort, again, we want to arrange these characters such that FFT and NTT are not present. How can we fix it, right? Because there's going to be a degree of, and if we see FFT, FTT, and NTT, right, we might want to maybe move the F and move the N or something like that. And so a good problem-solving strategy is when you're thinking of something that's very specific to the problem, you want to think more generally. Think if there's a general process that you can apply on the input in order to maybe fix a minor issue that you're having. And so another process that's very related to sorting is reversing. So let's just see what happens if you reverse it, right? If you reverse it. So if you reverse the whole string, so just flip it, you're going to have TTT and F. And so now you immediately don't have any occurrences of FFT or NTT. And so it's actually very easy to see why sorting it first in alphabetical order and then reversing it is actually the correct algorithm. And so obviously this is not the only one. However, it's one that's very easy to understand and one that's generally applicable and not limited to any one character. The reason why sorting the string and reversing the string afterwards can solve the problem is that if we look at our original batch strings, note that F comes before T and N also comes before T. And so if we simply have all of the characters arranged in descending order, so from instead of from A to B to C, we go from Z to Y to W and so on. We know that there can't possibly be any F's next to T's and ends next to t's in that order, because everything is in descending order. And so this is our general algorithm. Let's implement this problem in code. So here I have my pad, and if you're starting with a blank pad, you usually want to include some libraries. And so and I'm coding in C++ here, so let's include bits/stdc++.h. And so that's going to be a library where all of your standard input-output streams, your math libraries are going to be included. And so now it's very common to use the standard namespace. So let's just type using namespace std. And so that's for reducing the amount of characters you have to type. All right, so now we're going to code our main function. And if we go back to the problem statement, we can see that there are t test cases, and so each test case is going to be the problem we're going to solve. And so we're going to first read in the number of test cases, which in the sample input is going to be 5, and then loop 5 times and read in the string that we're going to rearrange. And so let's just do that. So here I have my main function, and I'm going to have t test cases and read in the number of test cases. And now I'm going to loop through all of the t test cases that I have and read in the string. That's going to be the string that we're going to rearrange. And so now we already know the general algorithm that can be used to solve the problem. So now we just need to sort in non-decreasing order and then reverse the string. And then we're going to print out the string. Now obviously we're going to just return 0. And so now let's just run it and run it against our sample input, which I've just copied. And so here, yeah. And here you can see that after reading in every sample problem, we've sorted it. So we've sorted it and then reversed it. And so each of these are obviously in reverse alphabetical order. And so now let's just submit and see if our algorithm is correct. Let's see. All right, it just got accepted. And so just to recap, often in edu rounds where you want to modify some sort of string or array, such as it satisfies some condition, try to think of the most general and easiest way to do so. And so in this case, the main leap of faith that we performed during this problem is that we noticed that F and T are in alphabetical order, and so are N and T. And so we basically could rearrange the letters in the string such that all of the letters are arranged in non-increasing alphabetical order. And so when all of the Z's come first, then all of the Y's, then all of the W's, and so on. So I hope you learned something new from this video, and take care.